the differentiation of exponential functions. Okay. Exponential function is given in the form of y is equal to e to the power x, where this e is a constant. It's called as Euler's number. Okay. Before that, we have to know some facts about this function or this e to the power x. Okay. This value of e to the power x can be given in the equation of x to the power 0 over 0 factorial plus x to the power 1 over 1 factorial, x to the power 2 over 2 factorial, x to the power 3 over 3 factorial, plus it goes up to infinity. Okay, what is this factorial? It's a multiplication of numbers, right? We will go from factorial 2. 2 factorial means it's the multiplication of 2 into 1, which gives 2. Factorial 3 means 3 into 2 into 1. It gives 6. So by that the factorial 1 is given as 1, and we also note factorial 0 is also 1. So from this we can rewrite this as a form of like we know that this will be 1. So 1 plus x over 1 factorial plus x to the power 2 over 2 factorial likewise. Okay. So from this equation we can get to know the nearest value of e. So e can be written e to the power 1. So we can write 1 plus x means 1, no? So 1 over 1 means 1 plus 1 over 2 factorial plus 1 over 3 factorial likewise. So it will be the nearest value of 2.7183. And let's do the differentiation of an exponential function. We take the equation as y is equal to e to the power x. Okay. To define this from the first principle, we have to take the thing like if we change x by delta x, the y will also change. So the change will be indicated as delta y. So here we will get the second equation, y plus delta y is equal to e to the power x plus delta x. So here we get two equations. If we subtract first equation from the second equation, then only we will get the delta y. So if we subtract first equation from the second equation, we will get delta y is equal to e to the power x plus delta x minus e to the power x. And with the knowledge of with powers, we know if two powers are added, we can simply write in as a multiplication. So we will write this as e to the power x into e to the power delta x minus e to the power x. So if we take e to the power x, which is common in both things, so we will end up with e to the power delta plus delta x squared over 3 factorial and so on when delta x tends to 0. So e to the power x into it will goes like when delta x becomes 0, this value of this fraction will be 0. So everywhere it will be 0. So e to the power x into 1. The answer is e to the power x. So the differentiation of an exponential function e to the power x with respect to x also e to the power x. Now we are going to see about the logarithmic functions of this exponential function. Okay, we know, right? Y is equal to e to the power x. We can write it in a form with log. How? Like log base e, y is equal to x. We can write this as this. Okay, this log base e can be indicated as ln, which means ln is the natural log. So we can write this as ln y is equal to x. So in calculus, whenever they mention log, it means that ln, natural log, not the base of 10. Okay. Now we see the differentiation of ln. So our equation is y is equal to ln x. So how can we write this? In the form of we have studied, e to the power y is equal to x. So to differentiate this, how we can differentiate e to the power y with the respect of y? We know already the e to the power x with the respect of x. What will be the answer? Into d to the dy by dx is equal to, what's the differentiation, is 1. So dy by dx, what's the differentiation? It will be same as e to the power y is equal to 1. So dy by dx is equal to 1 over e to the power y. E to the power y is equal to x. So the differentiation of ln x with the respect of x is 1 over x. We can use every rules of log with ln.